All right, IM1 classes. Today we're moving on with our geometry. We're talking about the segment addition postulate. This word here might be unfamiliar to some of you. A postulate is similar to a definition. We're not going to get too hung up on what a postulate is, but you just need to know it's similar to definition. And what the segment addition postulate tells us is that we can take two segments. If we add them end to end, then we can add their lengths together. That's basically all it says. Pretty simple. With that, these are the types of problems you deal with the segment addition postulate, finding missing side lengths. So we have segment TR, and S is in between the T and the R, so it's actually two segments. So from T to S is 4. We don't know how long it is from S to R, but we can see from T to R is 12. So don't overthink this too much. It should be pretty easy to figure out, like, what is that missing side length. If you need to set this up as an equation, I'll do that, but you should be able to do this in your head. The distance from T to S plus the distance from S to R is going to be equal to the distance from T to R. And this is what the equation would look like in using geometry notation. All right. TS, we can see it has a distance of 4. SR, we're not sure what that is, so we would change that to X. And then TR is 12. All right. If you solve this, you subtract 4 from both sides, you get X is equal to 8. So this missing side length is 8. Again, I don't expect you to write out the equations, doing all this. Something this simple, you can do in your head. All right. So let's talk about one where we will just do it in our head. So J to K, we don't know how far that is. K to L is 10, but J to L, the whole segment, is 22. So how much? So if this is 10, this is 22, how much is the missing side length? What's the difference between 22 and 10? That would be 12. All right, that easy. Don't get too hung up on the first few problems when you're just doing segment addition. So here, another one. So S to R, we're not sure. R to Q is 7. The whole segment SR plus RQ is 19. So if this is 7, the whole thing is 19. How much is left over for SR? That would be 12. The answer is D on this one. All right. It can get a little bit more challenging when you are dealing with segments that are, or you're not given the diagram. So you either have to kind of visualize the diagram or write your own. I'm going to sketch my own diagram here. So starting off, so AC, AB, or actually let's read these directions. Points A, B, and C are collinear. Remember, collinear means all on the same line. So A, B, and C can be connected with one straight line. B is between point A and C. So I'm going to do a segment. Actually, I'm going to change that to a black segment. And there's 3 points. So A, and I'm not sure how far apart they are, but it's going to be A and C are the endpoints, and it says B is in between. So here we have this here. I'm just going to label the sides. So A to C. So from A to C is 7. So the whole segment together is 7. AB is 1. So how much is left over for BC? That would be 6. All right. So here, let's do another one. Make sure you pay attention to how you're labeling it. So the general line is going to be the same. A and C are going to be the endpoints, and B is between those, and they're all collinear. So A, C, and B is somewhere in between. Label it. So BC is 7. So B to C, this is 7. A to B is 11. We want to find how long the whole thing is together. So 11 plus 7 is 18. So we actually, you just add those together. So if you're trying to find the whole length, that one's pretty simple. Just add together. Last one for this type. So we'll do it another long segment. 3 points. B is in between them. So A, B, C. So it says find BC. So we don't know what BC is here. So this is what we're going to try to find. I'm going to mark it with an X. AB is 9. And the whole distance from A to C is 11. So if this is 9 and the whole thing is 11, how much is left over for X? That would be 2. The answer is B. All right. So again, you just want to make sure that the 2 smaller segments add up to equal the larger segment. Right. Last type of problems you're going to see today is actually solving for X, using this to set up an equation to solve for a variable. So we're not actually finding the distance of LM or MN. We are just finding the value of X on these. So what we know to set this up, so LM, the distance from LM plus the distance from M to N is equal to the distance from L to N. And I think it does actually help to set up this equation here. All right, we know LM is 4x, so that's going to go here for LM. MN. So from MN tells us it is 3x plus 2. So we need a little bit more space. It's 3x plus 2. And then ln is the distance left over. So that's going to be 23. So from here, what we need to do is solve for x. So we'll put in a line of separation. First thing I'm going to do is combine like terms. Since these x's are on the same side, I can just bring them together. 4x plus 3x is 7x plus 2 is equal to 23. Subtract 2 from both sides. You get 7x is equal to 21. Last step, divide by 7. You get x is equal to 3. All right. Let's do another one. So solve for x. So careful, don't just add these. So what I normally see on these problems is kids will always just put the x's on the same side of the equal sign. Pay attention to the values. So t to s plus the segment length from s to r is equal to the whole thing tr together. So t to s is 12. So that whole thing is just going to go in here. S to r is this. So that goes in for s to r here. So plus 2x minus 6. And then the last part, this whole thing goes in for tr. I should color code this a little bit. But that's okay. So that's going to go in for there. So that's going to be 4x minus 4. I'll color code the next one a little bit better. So TS, so here now I just need to combine or solve. So I'm going to start off, I'm going to clean up the left side a little bit, simplify that. The 12 and the minus 6. So 12 minus 6 is 6. I get 2x plus 6. When I combine the 12 minus 6 is plus 6 here. Now I want the x's on the same side. Since these x's are on opposite sides, I need to eliminate one of them. So I'm going to subtract 2x from both sides. I'm subtracting the 2x because it's the smaller value. That'll make things, keep things positive. So you get 6 is equal to 4x minus 2x is 2x. And then now I can solve. So I get x by itself. I'm going to add 4 to both sides. 6 plus 4 is 10. And then the last step is divide by 2. And you get 5 is equal to x. All right. Next, one more problem. So for this one, so the distance from E to D is equal to the distance from D to C, or plus D to C is equal to the distance from E to C. Make sure you're putting the values in the right spot, so I'll color code these this time. So this whole thing goes in for ED. So you get 2x minus 13 plus the 7 is the distance from D to C. So that goes in for DC. Is equal to this last part here, x plus 4. That's going to go in for EC. Now I can solve this equation. I'm going to clean up the left side here. Negative 13 plus 7 is positive 6. So this is going to be 2x. So just to be clear, this is minus 13 plus 7 is positive, or no, excuse me, negative 6. Need the x's on the same side to solve, so I'm going to subtract x from both sides. The positive x minus x cancels out here. 2x minus x is just x. I'm going to add 6 to both sides to finish solving. So minus 6 plus 6 cancels out. I get x is equal to 10. All right. That is it for today. The assignment is on Edge Elastic. Make sure you email me with questions. Other than that, we'll see you guys next time.